Alright, you read the description, but you may not realize what's going on here. I'm trying a little experiment. I believe it's what the game programmers call a Easter egg. I'm embedding a little prize in here, a little reward for those of you who did the homework and actually watched the 8-9 video. You probably would have stumbled upon this little gem. Also, I'm actually going to do a quiz here. This is going to help you greatly for the next class. Okay, so let's get on with it. And yeah, you notice the font and everything. This is very quiz-like, don't you think? All right, number one is find the sum of this this finite geometric series. Okay, this is some g sub 1. G sub 1 I'm going to want to keep reference to, so let's keep that there. G sub 1 is 2500. And from there, I go from 2500, the next term of the sequence, this is a series because I'm adding them all up, the next term of the sequence would be negative 1500, then positive 900, then negative 540. So our r here, our constant thing is being multiplied, must be a negative number because it keeps flopping back and forth, positive, negative. We haven't done a lot of those. G sub 2 then, I know, is negative 1500, and that must be the first term times some value r. I need to figure out what that is. Well, then, oh, this is 1500. So to figure out what r is, all I got to do is divide the negative 1500 by 2500, and I find out that that is negative 0.6. Okay, that's great. Oh, by the way, I'm looking for sum of finite series. I need to know, in order to find the sum of the first n terms, I need to know g sub 1 times 1 minus r to the n over 1 minus r. That's a formula you will have access to during the quiz. I know everything about this now except for n. I don't know how many terms I'm adding up. I know I stop adding when I get to 116.64, but I don't know how many terms that's going to be. One way to do that is actually keep doing this on the calculator. 2500 times negative 0.6. This would be the second term times negative 0.6. Now this is the third term. Now I'm not adding these up. I'm just counting the terms in the sequence. That's term number 3. Term number 4, hopefully it's not too far. I don't want to lose track. 5, 6, getting close. Hello? Oh, I hit enter. What's going on? 7. Okay, it's the 7th one. If I wanted to be a little more careful about that, I could do that in the table, or I could use logarithms, but I'm pretty sure it's the 7th. I could actually just check that. It's supposed to be, oh wait, g sub n. Here, I can check it this way. If that's what I'm saying g sub n is supposed to be any g sub 1 times r to the n minus 1. That's how you explicitly find any term. I'm kind of hoping here that g17 here, which is, what did I say, 17? 7. I was hoping it would be 7. G sub 7 would be, I'm guessing, is 116.64. I'm kind of thinking that would be 2500 as a check times negative 0.6. to the 7 minus 1 power, to be the 6 power. Let's go back to the calculator and check that. Is it really that this is 2500 times negative 0.6 to the power of, and I was hoping that would be to the 7 minus 1, which is 6. Is that really this 116? And yes, it is. Oh, wait, it's negative. What did I do wrong? I don't know what I did wrong. Oh, because I should have put this in parentheses. Anyway, I got the right number, so I'm happy enough that that's really what it is. Okay, so yes, it is the 7th one. So I'm looking for S sub 7 here. Just found out that that is the 7th one. Okay, so S sub 7 here is G sub 1 times 1 minus 0.6. I gotta be careful on the calculator how I do that. To the 7th power now. Now notice that is different than this in the explicit formula. That was different in the formulas in the first place. Over 1 minus 0.6, which is 0.4. So this is, you know what, I like to do this on the calculator step by step. Let me show you how. Calculator. Do the exponent first. This is 0.6 to the 7th power. Let's take 1 minus that. Not 1 minus negative that, you crazy calculator. Second answer, there we go. 1 minus that, okay. So I take that, look back what I'm doing here. That I've done the 1 minus now, and now I multiply that times 2500. And divide the whole shoot and match by 0.4. Oh wait, by positive 0.4. 1 minus negative 0.6. Oh gosh. 1 minus negative 0.6 is 1.6. That was almost a big mistake. These negative ones are tricky. Okay. 1518.76. Let me do that where I can see it. This should be 1 minus negative 0.6. Oh, I can't see it. So this is approximately 1,518 and change. What was the change on that? 76. Okay. There we go. Let's go on to number 2. Okay, I just realized I can make these a little bigger if I don't get the answer blank up here. So here you go. Expand the expression. By the way, as long as I'm talking about that, expand the expression doesn't mean do that. Random silly joke number 1. Okay, expand the expression means, well, what is all this whole thing if you multiply it by itself 3 times? Well, that is involved in the third row of Pascal's triangle, which you look closely, and yes, I'll provide that on the quiz date, on the test day sort of cheat sheet thing. I found a nice printout of it, actually. So you could look at that and go, the third row is 1, 3, 3, 1. Okay, so in general, if we had something like x plus y, now we don't have just x plus y, we have more than that. But it takes x plus y and cube it. The coefficients on the terms of the expansion are going to be 1, 3, 3, 1. The terms in the expansion are x cubed at one end, y cubed at the other end, 3 x squared y's and 3xy squareds as those cycle on down. And since this is plus, everything's plus, everybody's happy. Okay. Well, this isn't just x plus y. This is slightly modified from that. It doesn't just 3x plus y. It's 2x plus 7y. So I can kind of just replace x. What used to be x now is replace 2x. So this is 2x cubed plus 3 times 2x squared times y. Well, y isn't just y anymore. Now it's really 7y. Plus 3, x is now 2x. Y is now actually 7y. Plus 7y cubed. And yeah, I can do some more simplifying here. I don't know. I kind of think you could stop right here, but the book, if you looked in the book, you looked at the answer key, they would actually simplify all these little parentheses, which are not that bad. 3 times 2 squared times 7 is going to be all my stuff here on the x squared y. It's still going to be an x squared y term if you look closely at the exponents, but now it's not just 3. It's 3 times this one squared times this one. So 3 times 4 times 7 is... this calculator's faster. What'd I say? 3 times 4 times 7, that's 84. Plus, now it's 3 times 2 times 49. Put part of that in my head. That's 294. And again, it's still an xy squared. And then it's 7 cubed. I used to know that in my head. I think it's 343, but I'll check. 7 cubed. Yeah, 343. And it's still y cubed. Okay, that's number 2. Don't you love these open-ended questions? Does it converge? And if so, find the value. First of all, what we know about converging series, if we know it's going to... The ones we know that are going to converge are infinite. Infinite. And the only ones we are really sure about. If I write cursive... seems to do better. If I write cursive twice, is it recursive? Okay. All right. If a geometric series, I'm thinking about R already, will converge if R is less than 1, or it's kind of like between 1 and negative 1. That means it will converge. Whoops. Converge. Okay. Which means there is a limit. If I have an R in there, and if I'm really sure it's geometric. Well, this one appears to be geometric. It looks like there's a G sub 1 here, and I have some R raised to the n power. But this thing, which looks like it would be R, the thing is being multiplied each time, because every time I go up another notch on 1 here, G sub 1, G sub 2, G sub 3, every new n here is going to add one more exponent to this. So that would be 0.2 times 10 thirds to the first. Then the next term is 0.2 times 10 thirds squared. The next term is 0.2 times 10 thirds. You can't really see that. 0.2 times 10 thirds to the 4th power. The thing I'm going to keep repeatedly multiply by is 10 thirds. Well, 10 thirds is greater than 1. So since 10 thirds is greater than 1, this thing is not one of these. This one does not converge. So I'm going to say no does not converge. 10/3 is too big. Next question on the quiz happens to be this. Same kind of thing, but slightly different series. This one, again, looks like it's if you start writing this out, this will be infinite geometric. It is starting at 5 times 4/9 to the first power. Then the next term will be 5 times 4/9 squared. Then the next term is 5 times 4/9 cubed. So what's happening here is I write out successive terms of this. As I go from term to term in the sequence, what's happening is each term is being multiplied now by 4/9. Then I get, whoops, that's a 9. And the next one would be the previous term times 4/9. Well, when that thing here going on and on and on, this ratio, and it turns out it is geometric infinite. When that ratio is less than 1, then yes, we have convergent. Should leave myself some space because I have to do this next. Okay, and how that converges, I had to find the sum of the infinite series. That's the easiest formula we have, remember? G sub 1 over 1 minus r. Well, what's G sub 1? That's what happens when n is 1. If n is 1, all I have here is 5 times 4/9, which is not hard, but it's not really pretty either. 20/9 divided by 1 minus r. Well, 1 minus, this is G sub 1, by the way, in case you look at this later. 1 minus r then is 5/9, if you think about that. 20/9 divided by 5/9 is like 20 divided by 5, and that, my friends, is 4. That's a nice convergent sequence. Series. It's a nice convergent series. Alright, 35th row of Pascal's Triangle. Oy, seems like a lot of work. 35th row is going to look like this. 35, choose 0, and then 35, choose 1, and then 35, choose 2. I think you see where this is going. And then this is how the 35th row looks. And so the first 4 entries are those. And I could use a calculator to figure this out. Well, this one's not difficult. This is part A, by the way. 35 choose 0 is always going to be 1. 35 choose 1 is going to be 35. It only gets interesting when I get to 35 choose 2. Now, I probably should have to do this on the calculator. This, if you think about it, is 35 times 34 divided by 2 times 1, which is 35 times 17, I guess, which is pretty big. But it's just as easy to go to the calculator and go, okay, 35 NCR 2. Which, like I said, should be 35 times 17 if I did that part right in my head, yeah? Yeah, 595. And I just want the first 4 entries, so this is a list. And 35 choose 3. 35 choose 3 is a whole lot bigger. 65, 45. Okay. And then what's the last 4 entries in B? Well, the last 4 entries end with this. 35 choose 35. The one right before that would be 35, choose 34. You could do these in the calculator, but you know what? You could save a whole lot of time here. What's 35, choose 35? Well, whoops, I'm talking and writing at the same time. These are the last 4. 35, choose 35. Well, how many ways are there to pick 35 things out of 35? There's actually one way to do that. How many ways are there to pick 34 things out of 35? Well, it's the same as picking 1 out of 35. It's like the math bus to the math party. I got room for, there's 35 people in the class, and I got room for 34. How many ways are to pick the 34 lucky ones out of 35 to get to go? It's the same as trying to pick the one guy who gets left behind. So there's 35 ways to do that. That will continue. Remember, these rows are symmetric, so the end of the row is like the beginning of the row backwards. So this is going to be 595. Again, you could do this in the calculator. You would get them the same way, but I'm trying to save you a bunch of time here. All right. This next question on the quiz is actually maybe even a little bit sillier. It's just asking you to evaluate 51C2. Well, since you have a calculator in front of you, don't think about this too long. 51C2. There you go, 1275. If you really wanted to, you could figure out what that comes from. That would actually come from 51 factorial. 5150, the first 2 numbers like 51P2, divided by 2 times 1. Which is 51 times 25 in the end, which turns out to be 1275. Okay, that's more than half the quiz, but I'll come back and finish the rest in the next video.